Hi, everybody. Just want to talk about completing the square because I think sometimes people forget it and they don't always like it, but it's kind of like once you do it, you kind of like it. So a perfect square, obviously math is like 25 or 36 or 81. They all have square roots, right? They're all perfect squares. So a trinomial square in algebra is, again, something that has a square root or it's a perfect square. So like this is the reason you can take the square root is because all of these can be written as squares. So obviously you can square root it. You can cancel the squaring and the square rooting because they're inverses. So in algebra, we kind of have the same thing. So when you get something like x squared plus 6x plus 5, you know, that doesn't make a nice square. It will make a rectangle. That's what, x plus 5 and x plus 1. But it's not going to make a square. Okay, if you remember factoring, remember like you need to get the 6x, so like the 5 there and that add up to 6, but then 5 times 1 is 5 if you remember factoring. But our goal is to get a square. Well, that's not a square. But say I give you something like this, like kind of a fill in the blank, you could make it be a square, all right? And so if you think of factoring, you have an x, and you have a 6 here. So I'm going to put that in half. I'm going to do 3 and 3 to make it even. So like the reason I did 5 and 1 here is because 5 times 1 is 5, but it also adds up to 6. So I need something that adds up to 6, but I need the same number twice because I want it to be a square. So 3 and 3. And so plus and plus. And see, this would be a square. Like it would be x plus 3 long, x plus 3 wide. So how do I know what to fill the blank in? Well, first would be, you know, like there's going to be an x squared in this corner, and I'm going to have 3 x's over here, 3 x's over here. And then what's going to end up in the corner? Well, 3 times 3, there would end up with 9 little squares in the corner, because FOIL first is x squared, outside inside is my 6x, and then my last is 9. So that I'm basically completing the square. I forced it to be a perfect square. And again, notice that it has an exponent, okay? I can write this algebra with an exponent. So how do I do that? Well, it depends on, it needs to be nice up front. So meaning just a 1, right? We don't want anything else there. So if I have x squared plus, say, 24x plus, okay, and we're filling in the blank, I know that it's going to be a square, so it's going to be x and x, and I know the same number is going to have to be on both sides. So 24 divided by 2 is 12. There's going to be 12 on each side. All right, and so then if I think about, okay, my x squared is going to be there, I'm going to end up with 12x's there, 12x's there. What ends up in the corner? Well, 12 times 12 is 144, ends up in the corner. So I take this number, I divide it by 2, and then that tells me what to put in my factors. So if I take 24, divide by 2, I get 12 and 12. And then if I do FOIL first, outside, inside, last, I know 12 times 12 is 144. And again, this is a trinomial perfect square right there. Now, what if it's not that pretty? Because you're like, oh, Julie, 24 is pretty nice. Yes, it is. So happen if I give you something like this, and you're like, well, shoot, you're not being very nice to us. Well, you know, fractions are fractions. Get over it. We're fine. In trig, we love fractions, so you have to get used to them. So how did I do it here? I split this number evenly between my square. Well, you know what? Squares can have fractions. 9 divided by 2 is just 9 divided by 2. You don't even have to make it into a decimal. Just take 9 divided by 2. All right? And so you get your x squared in the corner. Excuse me. X is going this way, x is going this way. And in the corner, you get the fraction times the fraction. So what is 9 over 2 times 9 over 2? Multiply straight across, 81 over 4. So that's what you added to the problem. I mean, these were original, but then you added those in right there. So 81 fourths. So then when you factor it, x plus, the number you get when you divide by 2 is actually what ends up in here. Because again, if I square this, notice if I square root it to go backwards, I get it. Square root of 81 is 9 square root of that. So you're going to have two things like this. And you can check your answer. Like, if you're like, well, it doesn't give me 9. Well, let's check. First is that outside inside would be what? 9/2 x plus 9/2 x equals what? 18/2. Common denominator, don't add those together, and I get 9x. Yeah, it works. So you can make sure it works. So that's if you have a odd number, you're going to end up with fractions because you're going to divide that by 2, and each side is going to be that, so that number goes there, and then to get the number that would be like in the corner, you would just square 9/2, or, multiply that. That's up to you. All right, what if there's a number out front? That's a problem. Okay, so we mainly deal with that. So if I have 3x squared plus 4x, we don't really usually complete the square there unless it's an equation. All right, so if we're going to solve an equation, then we would have like this equal to say it's equal to 4. I don't even know if that exists. That's when we would do it here. And what we would do is we would divide everything by 3, but we kind of need an equation to do that. So it probably won't be a fill in the blank thing. We get x squared. See how that turns nice now? And then I'm just going to leave this 4/3 over here. So the difference here is we're completing this square to solve an equation. Back here, we were just trying to figure out like what the expression was. Like we weren't solving. So if you're solving an equation, you can use completing the square. And so I had my equation. I divided because you want this guy to be a 1. All right. And then what we're going to do is we're basically going to, kind of do something to both sides here. So we're going to use the idea we did before. Make this a perfect square, divide by 2. So if you forgot how to divide fractions, multiply by the reciprocal. And you can use a calculator that has a fraction key. What is that? 4, 6, or what is that? 2/3, right? And you could have done that. So 2/3 is what like my two things are going to be. And so there's my 2/3. And so what do I add to both sides because I did that? Well, 2/3 times 2/3 is what? Is that 4/9? Which again is that number divided by 2 and then squared. So we divided by 2 and now we're squaring it. All right, so we're adding, what did I just say? 2/3, oh, here I am, 2/3 and 2/3, 4/9, sorry. All right, so I got rid of my coefficient, divided everything through to do that. Same as what you did earlier, take half of this, okay, and then that gives you like your 2 parts. And so you can either square 2/3, like just take 2/3 squared and get the 4/9, or you can kind of see it better here maybe. All right, and then now what we do is we would write x plus 2/3 squared. And then what do I have over here? 4/3 and 4/9. I'm going to get a common denominator here. Was that 12/9 and 4/9 is what? 16/9. And it should be something that has a nice square root. You know what I mean? It should work that way. And so now we're going to solve. That's the difference. We're solving by completing the square. So you're going to square root both sides. You get 2 answers when you do that. So plus or minus 4/3. And then you subtract 2/3. So x equals, all right, so what do we have here? A positive 4/3 with a negative 2/3. So what is that, 2/3? Or a negative 4/3 with a negative 2/3, which is what, a negative 6/3? So is that a negative 2? And then those would be my 2 answers. So that's when you use completing the square to actually solve it. I don't know. I mean, I suppose it's possible they could maybe do something like this. Like if I give you 4x squared plus, trying to think what they might do. 20x plus this one maybe, and told you to like fill in the blank to make it a perfect square. I suppose if they did that, you wouldn't be able to divide both sides by 4. So what you'd have to do is factor it out. And then I guess since we're doing something here, we're going to have to subtract over here to fix the error. Because we don't have an equation to like do both sides. So we're going to have to fix our error by subtracting later. All right, so we couldn't divide both sides by 4 because we didn't have an equation. So I had to factor out the 4. I took the 4 away from that, divided by 4 there, and here's my little blank. And I know if I'm going to fill in this blank, I got to fix it over here. This is like the error because I'm doing stuff to things. This is where you have to be careful, I guess, is see how this is 4 times that? So the error is going to be 4 times that as well because this is going to get multiplied by 4. All right, let's do the math. Divide by 2, and then you're going to square that. So like top would be what? 25, bottom would be 4. 25 fourths. Because again, what you're doing there is you have a square and you're taking half of them over here. So half up here, half over here to make a square. And so that times that gives you kind of the things that are in the corner. All right, but notice your error, you can't just subtract 25 fourths because your error is like the distributive property. That 4 is part of that error. So I'm going to do 25 fourths here. All right, so this again, I guess, is if they're going to have you try to do this without being an equation. So what do I get then? I have 4 parentheses x plus 5 over 2 squared. And again, if you're like, how do I know to do that? Again, what's half of that? That's that number. Or what's the square root of that? 5. What's the square root of that? 2. It all should work out. And then my error is this guy. So let's see, 4 over 1 times 25 over 4 is what? Minus 25. And notice you're like, well, that doesn't look like a perfect square thing. It kind of, this is the difference of 2 squares, but, you kind of have the perfect square thing here and there, but overall, it's not a perfect square. This part is. That part's the fix for the error. All right, hopefully that helps. Again, we will get better at this stuff as we go, so just want to try to bring back as many memories as I can. So take care.